Hello, hello.
Hi. Hi,
Hey, and welcome.
everyone.
Welcome
Yes.
everyone to Azure User Group Sweden. My name is Håkan, and together we have my colleague Jonah.
Yes. Hi, everyone. Welcome again to a new session of Azure User Group Sweden. And we're here today to do a workshop, a 2 hour workshop, IoT Services workshop, with our special guest today. So, should we welcome our guests on the stage?
Yeah, we can say a couple of things here about
Yes.
our code of conduct.
Yeah, so before we get started, we would like to remind you about our community code of conduct to be nice and friendly, be respectful to others, and be inclusive in your comments and your questions. And for details about the code of conduct, you can click on the link or visit the information in our meetup group. So, yeah, welcome everyone. I see we already have people on the stream. Welcome, Gabriel and Gopal. Glad you're here. Thank you.
Yeah, so then I think we can introduce our guest here for today, which is Sarwan. Hello,
Yeah,
good morning, good afternoon.
hello, good evening, Hakan and Jonah. Thank you for giving me this
Yes.
opportunity. It's been a nice pleasure to have this workshop with you both guys, actually. Yeah.
So
Uh,
where are you tuning in from, Sarwan?
yeah, actually, I am from India, in the state of Tamil Nadu, and I'm living in a city called Chennai. Actually, I am actually working as a senior engineer in the industrial Internet of Things, in L&T Infotech, actually. I have been having around total experience of 1.9 years of yeah experience in information technology, but in actually if you see in IoT and Azure IoT, I have around the more than of 6 years of experience in it, actually. So actually, I hope so actually this workshop will be really interesting for the people around here who have been joined, and then actually this workshop will be taking or makes them to know what are these IoT services available in Azure, actually, and how can they leverage it wisely to build a use case, actually. They for the IoT yeah, use case, and it will be yeah easy for them to play the things around, actually. So this workshop will be based upon the concepts which are really basic to in IoT, which are actually associated to the Azure user group. So actually, if you see, I hope so. Actually, we have some hands-ons, and then actually we are also have some good the slide contents as well, actually, so they can which can be shared later this the call also with them, actually. Yeah, so they can be able to have a look on it later the days also. So yeah, yeah, I hope so. It will be a great webinar for them, actually.
Yes. Thank you.
Yeah, nice. Yeah, so then I think we just hand over the stage here to you,
Yeah,
Sarwan.
sure, Akan. Yeah, yes,
And
Jonah.
let's see here.
Yeah, can I go ahead, Akan?
Yes, please go
Hello.
ahead.
Yeah, can I start?
Yes, yes, the start. Go ahead.
Yeah.
Thank you.
Yeah, hello everyone. Actually, it's good morning and yeah, good afternoon to everyone. Actually, and then yeah, today we are going to see a workshop which is related to the Azure IoT services. Actually, okay, in this workshop, as I told before, actually, yeah, you can be able to leverage some important Azure IoT services, actually, which will be useful for your IoT use cases, actually. So yeah, I hope so. If you have any queries in between of these slides, or you want to ask me any questions, or you need any clarifications, you can put it out in the chat box, and so that it can be addressed by me, actually, then and there, actually. Okay, so I want to be this workshop should be an interactive one, actually. Yeah, because in this workshop we have some good hands-on. You can see uh, how the some important services of Azure IoT are working, and yeah, how we can yeah, be able to pass the data from a simulator to your cloud platform, yeah, Azure cloud platform. Okay, so I hope so. It will be a great thing. Uh, mm, and now we will be going inside our contents actually. Okay, yeah. Before going into the Azure, actually, do you see actually, first of all, we need to know what is Internet of Things actually. I hope so. Actually, nowadays, for past 5 years, actually, you've been seeing this terms like in young IoT, AI, artificial intelligence, ML, machine learning, and all. Actually, it's actually buzzed around these information technology places actually. So what is meant by, first of all, the Internet of Things actually? Okay, if you see what is meant by an Internet of Things, it's nothing but a network of internet connected devices that communicate embedded sensor data to the cloud for centralized processing. What is this term actually? Okay, actually, if you see, you have some a number of devices actually which is connected to the internet. Actually, they need to be communicated with each other, and they are sending the data which are associated with this uh, um, the these devices to the cloud. And from in the cloud, actually, they have been processed very much in a centralized manner actually. Okay, so that is the purpose of what the term of this Internet of Things. And then actually, if you see, we have nowadays actually this IoT is implemented in each and everything, like yeah, for example, wearable which you have for the guilt related purposes actually. And in that, actually, if you see, you have your not bit rate, and then actually your uh, yeah, pulse rate, and can be monitored efficiently, and it can be sent to the collected, and then it can be sent to the cloud actually. In that, actually, if you see, if any issues or anything have been you guys have been experienced, or this cloud actually, the data which is sent to the cloud will be processing it, and it will be and which they will be implementing some analytics actually to the data which was sent from your wearables. And then actually they will be calculating that some predictive analysis they might do actually to tell if you in future actually, yeah, what will be the heart rate, and yeah, pulse rate will be actually. So that kind of some interesting yeah, use cases are there in this IoT actually. So if you see, this is the term and example for your Internet of Things actually. And if you see, yeah, if you see actually, uh, if you see here, actually, the device actually side, which is made up of some individual devices which are actually called as a things that access a data sources, because from these devices only we are actually taking the data and actually pushing it to the cloud platforms. And then actually the cloud side will act as a, it's a platform where the data which is sent from these physical devices will be gathered, and it will be provided to the resources for further analyzing of it actually. Okay, so this and this communication between from device to cloud and cloud to device will be a uh, uh, it's a yeah, this communication between this device to cloud and cloud to device is a two-way communication where the data will be gathered, and it has been uh, sent for analysis, and later the analyzed data will be sent back to your device as well actually. So this is the way actually how the IoT works, and the data from your device will be sent to the cloud, and cloud to data has been the cloud to your device was actually sent actually. Okay, yeah, this is what about the Internet of Things actually. If you see here, there is an IoT example. Actually, we have an example here. Suppose a small town is trying to figure out how to price water during the summer months. They want the town to look nice and enable people to keep their lawns green, but they also don't want people wasting their water. Okay, so which is in shorter supply during the summer. The towns officials need the data to determine how often people actually need to water their lawns to keep them green, and will use the data to help inform what price they should put on water usage during the summer. Okay, this kind of typical use cases are now becoming in the industry, like how to utilize the resources in an efficient way, or remote monitoring has to be done on your devices and all, actually will be coming under this as an IoT use cases actually. Okay, and then actually if you see like this, actually we have been getting some good business use cases and IoT use cases in the future time, actually, so that all the resources are utilized in an efficient way actually. Okay, and then if you see we have the uh, if you see actually when we are discussing actually these devices are connected to the internet, it is important to note that this might be an indirect connection to a middle management device actually. uh, actually yeah, if you see actually there are some business goals, and then um, which was they mentioned, yeah, here for the consumers and businesses, like actually they have some device characteristics actually, like that the IoT device has to be connected to the internet, and it should have a security features, smart features, communication capabilities, configure, it should be a configurable one and a programmable one as well actually. And if you see a consumer versus business implementations, if you see, their intentions and goals should be achieved, and the data which is gathered by these devices should be analyzed for the further analytics actually. Okay, uh, then if you see actually yeah, there are some strategies to implement this IoT. And actually, if you see the implementer, who the person who is going to implement this IoT use cases, actually, will we should have the process considerations and design considerations as well. Actually, what is meant by a process consideration and design consideration? The process consideration means actually that the implementer should be clear about whether the implementation which you are going to do will be a short term one or a long term one, or and then it should, whether it should be carried out in a phased manner or in a complete segment manner, like that actually. And then if you see in the terms of design considerations, actually the person who is going to implement an IoT use case should be very much thorough about his architectural approach, solution governance, technical strategy, how they are going to implement this, and the team members and other resources who will be suitable for this IoT application. This team members and other resources, actually, for actually, if in case actually I have an IoT project with me, actually, if I want to form a team, actually means actually I need some four, at least three types of the persons to implement this the use cases actually. For example, a device engineer who should know how to get the data from the things which are from many things, like the assets in the industrial, the shop floor, or from the variables, etc. Action not only might be the things actually that the device engineer should be implementing the device, and yeah, he should know how to pull the data from the sensors of the devices, and then actually he also should know how to push the data to your cloud platform. And the cloud engineer being required in this project, what's his process is, he need to route the data efficiently, and he needs to know what are in IoT services should be utilized here actually. Because if you see, the Azure IoT cloud engineer plays a vital role in this entire use case, because he is the person who will work on this 60 to 70% of the architectural work of your the IoT use case, because he is the person who knows actually how to send the data to your uh, uh, pull the data from your devices, and then actually send it to various IoT services to perform the analytics process or for the storage purposes actually. Okay, and then comes the data engineer who will pull the data from this big data sources where this cloud engineer has already stored for the streaming data of these devices actually. And then actually he will pull the data and do some analytics and will be sending it to an application developer who will be showing it as a dashboard to us actually. Okay, so if you are considering IoT use case actually, we need some 3 to 4 types of developers actually, like a device engineer. If it's an Azure platform, you need to go for the Azure IoT developer. And then actually the data engineer or data analyst, or sorry, the data scientist who can pick up this data and do some data analytics actually. And the finally comes the application developer team who will frame the APIs and dashboards so to get the data from this data source actually. Okay, and then comes your this is your IoT architecture where actually if you see this architecture actually this is like some core subsystem, because actually if you see here, sorry, if you see here we have an IoT device which will be used for uh, provision and send the data from the device to cloud and cloud to device. And actually from here, actually from the devices which is IoT devices are nothing but your physical gateways, will send the data to the cloud gateway which is nothing but your IoT hub actually. Okay, from IoT hub actually we can either send this data to your stream processing, either to a stream analytics or event hubs which are there in your Azure ecosystem, and then or it can be sent to some storage accounts like a blob or any database kind of things actually. Okay, from this actually if you see from the streaming process or from storage only actually, if you see actually it will go for a business integration and for the visualization and device reporting as well actually. Okay, if you see this entire plot will be considered as a things, and this part the thing which is here actually considered as a insights, and this is the action part actually. Okay, you can ask me actually why we need some two types of diversions are here. We can send the data directly to the business integration, because if you want to have a streaming data to be analyzed actually, we are need to send it to a stream processing. But if you want any data which has to be stored for the future purposes, it can be stored in a storage part actually. These two parts are called as warm part and hot part actually. Okay, the warm part is nothing but which consists of the streaming data, and the cold part is nothing but actually the part where the data consumed actually will be utilized for the future purposes actually. Okay, and then actually the simplest way of what to tell actually explaining this architecture is actually it's nothing but it's a central message hub for guide directional communication between an IoT application and devices its managers actually. This is a simple term to mean this architecture actually. Okay, till now anyone has any doubt guys actually, any queries you have? Okay, uh, then I'm moving forward. Actually if you see next one is called a data flow and deep processing. Okay, what is only data flow and processing? As we seen our architecture before actually, you see an IoT solution is all about the data actually. Okay, for example in the architecture also, if you see the data flows from the devices and it's get processed to some storage or routing, and then analysis to get actions and displays actually. Okay, so what is this data flow and the what the processing means actually it's a things which generate the data. Things is nothing but your assets or any devices actually which generates the data and gives the insight based upon the data generated, and the then the actions has to be performed based upon the insights which is covered in the previous steps actually. Okay, this is the main and the basic implementation of your IoT architecture actually. Now you can see each and everything actually in a uh, separate thing actually. If you see here, this storage actually, what is going to be this in this storage actually, what we'll have actually, what kind of data will be stored actually. What this storage was includes in a memory caches, temporary queues, and permanent archives actually. Okay, for example, if you see this storage, as I mentioned earlier, it can be a blob actually, or it can be a flat file, or it can be a the database, etc actually. And routing, what is going to be a routing actually. Actually routing is nothing but from where to where this data has to be passed actually. Okay, yeah, for example, if I'm sending a data from a device actually, it should go to a it should go to a particular place actually, and rather than to any other place. So the routing has to be carried out actually in a efficient way. The routing is nothing but actually it should it's a concept of making the decision on what data should go to which direct target and when actually. For example, if I am sending a data from millions of um, yeah, millions of devices actually. Okay, yeah, I need a data of a particular device alone to go to a particular target means actually in that place in routing will plays a deficient role actually. Okay, and then actually if you see analysis actually, analysis is nothing but actually is used to run data records to a set of conditions, and can it's also produce different output data records actually. The main purpose of this analysis actually is to produce some insights while maintaining the original data. Okay, and then actions and displays actually. Actions and displays is nothing but actually the data which is analyzed and had made some insights actually has to give the data to a trigger actions, and then actually based upon the insights given by this analysis, the data can be reported in the form of the reports or dashboards, etc. Okay, yeah, yeah, this is the data flow and processing of your IoT architecture. What are these IoT hardware components actually? Okay, what type of IoT hardware components we have actually? We have the IoT devices will be there actually. Okay, which can be an IP enabled devices or non IP enabled devices actually. Okay, well, actually, IP enabled means that actually, uh, from the earlier that we can come to know that this IoT does not require the devices to have any direct or internet connectivity actually. Okay, so that is called in IP enabled devices, and non-IP device using Bluetooth or Zigbee can communicate with other IoT engaged device which has the internet connectivity actually. And nowadays actually we have been using some IoT edge devices like a Dell yeah 5000 series or that kind of gateways are used actually, which is a powerful gateway actually, which runs on some specified protocols to push the data to the cloud. And apart from this IoT edge devices and IoT devices, actually, we have some other IoT hardwares also like network switches, routers, etc. Actually, so this how to choose this IoT hardware components means actually we need to it's purely based upon your use cases. Yeah, what you are going to um, take for this. Uh, taken actually. Yeah, for example, if I have a logistics based use case actually. I need to use a GPS based IoT device or tracker actually to pull the data from your vehicle actually, or from or the packages which have been sending to these logistic systems. Okay, so based upon your use case, this IoT hardware should be the chosen actually. Each use case will have a different purposes, and this different purposes uh, can be yeah, fulfilled by yeah, the different the IoT hardware components only actually. Okay, and then if you see actually, this is the Azure IoT services and technologies, or these are the services which have been used in Azure for IoT and data analytics things actually. Okay, we have two types of things called PaaS solutions and SaaS solutions actually, software as a solution and platform as a solution actually. And we as a PaaS solution, we have Azure IoT solution accelerators in your Azure cloud environment actually. And if as a SaaS element, we have Azure IoT Central and Microsoft Dynamics Connected Field Service actually. Okay, so based upon your use case actually, this solution acceleration or based upon your budgets also, these solutions has to be leveraged from the Azure cloud. And then if you see here past technologies, if you see sorry, yeah, if you see here actually device support and IoT, for which particular thing actually, which services we need to leverage, like that this table has been given in. For this, if you see for IoT based use case for device support, we need to leverage Azure IoT device SDK, Azure young IoT certified devices, security program for Azure IoT, and Windows 10 IoT core actually. Okay, and for the IoT based the services which are present in Azure or Azure IoT Hub, Azure IoT Edge, Azure Time Series Insights, Azure Sphere, Azure Digital Twins, Azure Maps, IoT Hub, the device provisioning service, Azure Functions, and Azure ML as well. Actually, okay, these are the services, the major components actually, which are leveraged by the Azure IoT platform. And then for the data analytics, we have Azure HD Insight, Azure Data Lake, and Azure Cosmos DB actually. Okay, to perform the analysis part actually. And then if you see the visualization and integration actually, if you see actually, we have Azure Logic Apps, Azure Microsoft Power BI, Azure Active Directory, Azure Web App, Azure Monitor, and Microsoft Flow as well actually for the visualization and integration. Okay, these are the services which are leveraged by the or which has been included in Azure for two can be, it can be leveraged for your IoT use cases and make them as an efficient one. Okay, and if you see here actually what kind of device software, IoT device software actually I can use, and what kind of programming languages I can use actually. Okay, usually if you see actually what in the devices side, we have actually we some operating systems support the current IoT trends are Windows 10 IoT Core, Ubuntu Core, React, KNX, Android Automotive, and we have some more things in that list actually. But very largely used operating yeah, systems in the um, this IoT nowadays in IoT is actually Windows 10 IoT Core and Ubuntu Core. These two operating systems will be installed in IoT devices or IoT edge devices, and on top of this operating system, you guys, the device engineer, which I mentioned earlier, will be writing the programs to extract the data from these sensors actually, which is attached to the machineries actually. Okay, so the programs which we are writing on this these devices will be getting the data from this sensor which are connected to the machineries, and it will be pushing to the cloud actually. And you can see what kind of programming languages we can use to extract the data from this sensors which are sensors and send the data to the cloud actually. Some of this is supporting programming language which which have the SDKs and which have some supports are C, C++, Java, C Sharp, and Python. All these programming languages, for all these programming languages in Azure IoT has a predefined SDKs which can be used in your programs to make the use of this SDKs to get the data from your edge devices actually. Okay. And if you see, we have some software development kits. As I told, we have some device SDKs, device provisioning SDKs, and service SDKs as well, actually. Okay. Next, we are going into a important topic called the, which is a very major, uh, which is a very important the IoT service actually, which is on heart of the IoT service of our Azure ecosystem. Okay, that thing is called in Azure IoT Hub actually. Okay, so before entering into it, actually, I explained your how the architecture should be and which kind of people needs to work and how the things has to be done in an efficient way for a IoT use case and all. Till that, if you have any doubt, you can ask me. Any queries from your side, guys? No, can I move on? Okay, fine. Yeah. And then actually, if you see,
Are you still there?
hello, Jonah. Hello.
Yeah, you got disconnected. I thought
No, no, no.
we lost
Yeah,
you.
yeah, yeah.
Yeah.
Actually, there
Um,
I am adjusting my mic actually here. Sorry. Yeah.
yeah, it's okay. I hope the audience they don't have any questions so far. So to those that are watching, if you have any questions about the session, feel free to post it in the chat. Yeah, go ahead. Thank you.
Okay, Jonah. Yeah, sure. And then actually, if you see what are the features of this Azure IoT Hub, first of all, what is meant by this Azure IoT Hub? Actually, as I told, actually, it's a very important service of Azure IoT, and then actually, it will act as a gateway between your device which is sending the data to the cloud, and it will consume it and is route it back to the some important services of Azure IoT. Okay, what are the Azure IoT Hub important the features means actually if you see they have some security, scalability, routing, service integration, device management, and monitoring. These things and all actually while we doing the hands-on, I will explain you actually in which places we have this thing and which now it can be monitored or can be viewed in the Azure portal actually. Okay, and then actually if you see
Yes, we have actually a question now from an audience. Let's see, let me show it. So we have a
yes,
question from Gabriel.
okay.
Can I connect an Arduino or Raspberry Pi microcontroller to Azure?
Yeah, actually, you can connect your Raspberry Pi to your Azure, actually, and I hope so. Raspberry Pi, it's not a microcontroller; it's a single board computer. But in the case of Arduino, by using a yeah ESP32 or ESP8266, you can send the data to your Azure or any other cloud platforms as well. Actually, yeah.
Okay, that's good. I have a follow-up question to Gabriel's because I myself has a Raspberry Pi at home, and I want
Okay.
to develop it with Azure and Azure Functions. But do you have like, is there any? I mean, I'm totally beginner with IoT, but I know the basics. But is there any like programming languages that are specific to coding IoT to Azure? I mean, to those that are new in this technology.
Yeah, yes, Jonah. Actually, yeah. If you see, actually, currently we have been in the industrial point of view. Actually, if you send the data from the Raspberry Pi or from any other edge devices, actually to the Azure cloud, if you see, actually, if you take as in Raspberry Pi is an ARM. It's a norm based architecture we are been following there. So actually we need to go up with either by .NET Core, or actually we can go with the the Python programming language actually to send the data to the cloud actually. But I daily actually love to go with .NET Core frameworks actually. Yeah, because it's been daily lazy when compared to other frameworks actually to send the data to the IoT Hub actually from any devices.
Okay, thank you.
Yes, Donna. Thank you. Yeah. Any other questions, Donna, from the audience side?
So far, the audience are just listening to your session. No questions so far.
Okay, sure, Donna.
Thank you.
Okay. Yeah, fine. Yeah, actually, as uh, uh, as Donna asked actually, is there any particular programming language or to send the data from your Raspberry Pi or from any other development boards actually means actually, we have actually yeah, if you see actually nowadays actually we have the development boards have been programmed or it's actually default coming up with some Linux based OS actually. Okay, for example, if you take the Raspberry Pi as well, actually we have a Raspbian OS which is coming up with it actually. So in that case, actually we need to have a programming language which should be a platform independent one actually. The thing is actually, if you see, you can either use .NET Core actually with version 3.1 or 5 actually with the help of the DS code, or you can go up with a Python programming actually, which will be which is really useful to send the data directly from your Raspberry Pi to your Azure IoT cloud actually, or from in the case of Arduino actually, I hope so actually we can have a facility to code with C or C++ actually, or it's with using the Arduino C. Yeah, in that case actually you need to leverage the Python into it, and then actually you need to construct a program and send the data to the cloud actually. Okay, so it depends upon your development board. If you have a single board computer, it's really straightforward. You can use either Node.js or Python or .NET Core actually, since these platforms, this is languages are platform independent actually. But if you have a microcontroller actually, you need to either leverage the Azure SDK for C or C++ to make a coding and send the data to the cloud actually. Okay, yeah. And then actually, if you see what are the features of Azure IoT Hub actually, I've been told you actually, and then actually we are going to show you what are the IoT capabilities actually. Okay, yeah, I will rather after seeing it in the screen, I will be just showing it in your the hands-on the session. What are the tires we have there actually? What is the um, capabilities they have actually. Okay, we have a different young IoT capabilities actually. Okay, it's been classified as S1, S2, F1, basic, etc. Actually, like that. Okay, and then actually, if you see, these capabilities are differentiated by the tires, as I told you, S1, F1, and all actually. But actually, again, I'm telling you actually, if you this tires has been selected wisely based upon the use cases where your how much device per day your devices will emit to the cloud platform. Because if you are sending in some lakhs and lakhs of or millions of messages yeah, per day means actually, so you need to create a tire, or actually choose a tire in IoT Hub tire actually, which is relevant to that actually. Okay, but, if you're not, yeah, the choosing the relevant tires at the start of your use case actually, you might lose some of the messages actually. Okay, and then actually, if you see what are the capabilities we have in this free tier and basic tiers means actually, free, and actually if you see for basic tier actually, we have the device to cloud telemetry, which can be done in a basic tier and standard tier as well, and per device identity, and then message routing, message enrichments, and event grid integrations, HTTP, AMQP, and MQTT protocols, device provisioning services, monitoring and diagnostics. Till this actually it's common in between your basic tier and your standard tier actually. And then if you see actually cloud to from after this monitoring and diagnostics actually, cloud to device messaging, device twins, module twins, and device management, Azure IoT Edge, the IoT plug and play actually, or we will have a some costings, and it can be included in your yeah, S1 tier for, but for some basic hands-on, or if you want to learn anything, I hope so this basic tier will be a deficient one. Yes, since it doesn't cost anything actually. Okay, and in any case or in any situation, we can move from the basic tier to the standard tiers actually, which is based upon your demand actually. Okay, these are the tire deletions we have, which I have been mentioning earlier actually. Okay, if you see here actually, we have if you see here actually, we have different tires which have been mentioned. And then actually we can yeah able to downgrade and upgrade this deletions at any time actually. Okay, within an deletion, what it will actually, we need to pay for some certain units of messages passed, or it can be the auto scaling of these tires can be done by means of an Azure functions implementation as well actually. So if you see here in this, the tire edition D1 comma S1 will have a sustainable spin rate of 278 messages per minute per unit package actually. Okay, which means actually which can accommodate only 4 lakh messages only per day per unit. If you see this B2S2 actually, up to 16 MB of data can be sent per unit, for minute per unit actually. And then actually it can send actually for 4167 messages actually. That means it's already equal to 66 million messages we can send per day actually. So when the tire increases your based upon your usages, the message which needs to be consumed in your IoT hub also will be increased actually. So again, I am telling, before choosing your the use case, understand about it, how much data which your device will be sending out for each and every day actually, so that you can build an efficient uh, and scalable IoT hub in your architecture. Okay, okay. From you can ask me actually one question there actually. Okay, once I get the data in your IoT hub actually, where this data can be sent actually. Okay, this is the place where the concept called um, routing is coming actually. Okay, what's the thing, once I receive the data from my in my actually in IoT hub, I need to pass it somewhere actually to make it as an efficient one. So that in IoT hub, if you see, we have some built-in endpoints as well, and we have some custom endpoints as well actually. Built-in endpoints means actually, if you see here, sending a device to cloud, receive cloud to device, initiate fill uploads, actually this activities and all will be carried out actually in the built-in endpoints. But in custom endpoints, we need to create a custom endpoint based upon these services like Azure storage containers, or even tubs, or service bus queues, and yeah, service bus topics. Apart from this custom endpoints, yeah, if you want to directly send the data from your IoT hub to stream analytics, means actually in between, after sending to this endpoints only, we can leverage the things. Yeah, these are the basic endpoints which is yeah, offered by IoT hub actually. After reaching these endpoints only, from there only actually your data can be leveraged to many other yeah, services like Azure HD Insight, or Databricks, or many other places actually. Okay, and actually if the And in that case, if you want to include any serverless based architecture, means we can put some Azure yeah functions to leverage this data from these endpoints and push it to your particular or the desired target actually. Okay. Okay. What are the security the features if you have in this IoT hub means actually we have access control and permissions, and we have authentication security credentials actually. Okay. Access control and permissions means actually what I have the person who is an IoT hub owner has the access to give to whom I need to give the policies and take permissions who can leverage the usage of this IoT hub like that actually. In that, if you have hub level shared access policies and device level the permissions are there actually. Okay, and then actually authentication security credentials. In this case, actually, if I am my device is sending a big data to an IoT hub, on what basis actually this on what basis actually this data can be sorry yeah on what basis this data can be sent and we need to authenticate it that from my uh, device only the data is coming or not actually. In that case, if you see actually each and every device will have a what it will actually the symmetry keys or X509 certificates based authentication actually. Okay, so yeah, while actually these are is some security the features of your IoT hub actually. If you see here actually this is in IoT uh, this picture actually uh, give you the clear uh, things like actually yeah actually this is like the life cycle. Yeah, we need to plan and then provision, configure, monitor and retire actually. Yeah, I need to plan for an IoT use case and architecture. I need to provision the required yeah services, and then configure the required IoT services, monitor them wisely, and retire them when the data or the actually the device is no more required for me actually. Okay. You see, we have two types of Azure IoT devices. One it is called IoT devices, and another one is called the IoT edge devices. Actually, okay, what is my IoT device? It's nothing but a small scale standalone device actually that may that may collect the data or control other devices actually. Okay, but what is it? What is my edge device means actually? The edge devices have the IoT edge runtime installed, which can be used as your field gateway device itself actually. Okay, so this is the basic difference between your IoT devices and your IoT edge devices. We need a Azure VM or Windows VM to install this IoT edge runtime, and we can actually make this VM itself as an IoT edge and leverage the services of this IoT edge to get the big data from your sensors actually. Okay, and then actually if you see actually the stimulated devices can be used in various stages during the rollout of an IoT solution to represent individual device behaviors or to generate a telemetry workload. Actually, if you see actually based upon Azure IoT SDK, actually, um, nowadays actually we have been creating a lot of stimulated devices which can be used as a POCs for the various stages of your use cases to go out or perform some actions. Okay, so using that SDK you can actually create a stimulated device which can send the data to these Azure IoT services, or you can use your main equipments or devices to send the data also actually. Okay, if you see here we have a device catalogs actually which are all hardware certified which are all certified hardware devices to work with in IoT hub. I am going to this link actually, just a minute. Okay, I hope so this there is some error in this URL. Don't worry, I will actually will share this URL later this day. Actually, if you go to this page, actually, this the catalog.azure IoT solutions. Actually, if you see, actually, uh, if you see, we can be able to. Uh, Sorry. Just a minute, guys. I have some issues. Yeah, actually, in this catalog, actually, you can be able to see actually that what are all the devices are very much uh, notified to work with in IoT Hub, and then actually. And you can also take out from some devices as a stimulated device from this list to work out with it actually. Okay, and then actually these things I will yeah, Azure IoT device registration means actually we need to create a device in your after creating an IoT hub. Actually, we need to create an IoT device, and then actually we need to authenticate the type as symmetry key or X509 certificate, and then actually it will start sending the data to your or accepting the data from your external device, which is configured to send the data to your IoT hub actually. Okay, this steps and all we will be seeing it in our hands-on session. And this device twins are nothing but once you question your device, we have a device twin which includes what is a device state, metadata, configurations of your device actually. And actually if you see the IoT hub, we have a having a device twin for each device that connects to it actually. Okay, what are the properties we have in this device twins? Actually, if you see while we creating the device actually, these device twins actually will be created as a JSON format, which have the device app and backend actually, which are used to have a tags properties and desired properties and the reported properties actually. What is my desired properties and the reported properties? Desired properties means it will read, receive, and change the notifications, and it should be and the reported properties are used to read and change the notification as well actually. The device configuration is generally done actually using a feature called device twins only, which will be majorly used to configure your then the device which is created inside your IoT hub. If you see, till now anyone has any questions actually, guys? uh, Jonah, Did- yeah, do we got any questions there?
Not so far. No questions so far, but we wanted to share this one. The link didn't work.
Yeah, correct.
So I kind of like search it a bit. It looks like they updated the link to
Yeah,
the
someone
device
link has
catalog.
been correct. Yeah,
Yes.
yeah, yeah.
So this is the link, updated link, devicecatalog.azure.com if you want to see the certified devices for Azure IoT. Yes. No
Correct.
questions so far. Thank you.
Okay,
I
John.
actually I have a question,
Yes, yeah.
but maybe I wanted to ask a question in one of your presentations or list or earlier. You had something called Riot, and I wanted to know what is Riot is on your list.
Uh, 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 John, I can't get you actually. Got you telling Juno?
Riot. You had a list of devices that's supported, and it was like a thing called Riot, and I was curious what is Riot
It's
for.
an operating system actually. It's an operating
Ah, okay,
system.
okay.
Yeah, it's an operating system which actually used for which is widely used in this IoT edge devices actually. Okay, actually, but the popular IoT edge device operating systems which are used nowadays are Ubuntu core and then the Windows and IoT core only actually. Okay, so this diode and all will be used in some places, but actually the widely used are these two only for the industrial purposes actually. Okay.
Yes. Okay, last question. This is a random one. Not this is like, why do you think that it is important for developers or anybody to learn IoT
Hello.
development? Can you hear me?
Sorry, Josh, you have been yeah, yeah. Tell you.
Okay, I can repeat. Yes.
Yeah, sure.
Are you? Yeah. So, my question was, why do you think it is important for us to learn IoT development?
Okay. Actually, yeah, if you see actually in the future, actually, we have some good the openings and opportunities in IoT by 2025. Actually, if you see, we have some 3 trillion actually devices will be connected by means of this IoT. Once this by means of this. D- the smart city use cases which has been a these smart city use cases which has been implemented in all over the world main cities actually. Okay, the thing is that the opportunities are more to get be adapted to this the IoT uh, the use cases. And then actually why it is important means actually if you know the entire ecosystem of IoT only, it will be easy for you guys to implement or architect efficient yeah, IoT use case, and to get which will be in the later will be a DC one to implement as well actually. Okay, so only I'm telling actually that if you actually have a project which is based upon IoT, only one person can't able to do it actually, but actually we need some various developers like device engineer or a cloud specialist, and then an application developer or data analyst to do this IoT use case
Okay.
actually. So it's very important actually that if you learn IoT in now or then actually, in the future it will be a good opportunity in the means of jobs for everyone actually.
Okay. All right. Thank you.
Yeah, thank you, Jonah. Yeah. Okay, I'm actually continuing the thing. Actually, if you see, we actually we have been seeing this device twins I have been speaking actually. It's nothing but actually it's a the JSON file actually which have tags and desired properties and reported properties of your device which was created actually. And then if you see the tags, what the tags will have actually is a device metadata which can be accessible only by the solution backend, and the desired properties which have the JSON objects modifiable by the solution backend and observable by the device app. And then the reported properties. What are reported properties means actually it is modifiable by the device app, but being readable by the solution backend only actually. Okay, and then if you see. We have a what is known as device monitoring actually. If I created an IoT device in your IoT hub actually, if you see, we can monitor what is the status of your device and what is the health. The status means we are already know whether it is connected or not connected, and health means actually whether it is working or not actually. Okay, and then actually if you see the yeah, device retirement actually. So device retirement means actually, for example, if I don't want a particular device actually and I need to delete it or we need to retire it means actually, we can do it in two ways in Azure, like soft delete and hard delete actually. Soft delete means we can make the device temporarily at the disabled state, or we can be able to permanently delete the device itself, which can cut the communication of this device to the IoT hub actually. Okay, and I hope so actually this actually either the two ways actually if you see can the device determinant like disable and delete can cut the connection of this IoT hub device to the IoT hub actually. Okay, and then actually if you see actually from this in this from the previous slide, actually we can come to know what are is life cycle of these devices which are present in the IoT hub. And next we are going to see actually what are the developer tools we have to implement this in Azure IoT Hub actually. Okay, we have a software development kits, Visual Studio. We all know actually it's a popular ID, and actually the Visual Studio Code, which is in recent times it's gaining a lot of popularity actually. Yeah, because of its lightweight actually. And then actually if you have CLIs as well actually. And then actually if you see what are this Azure IoT Hub software development kits actually, it means actually what is the benefits of things actually. We can actually provide a future proof solution with some minimal code, and we have some futures leverage design for a complete software solution, and focus on our specific need actually. Okay, and what is it, it can be developed for a specific platform and for a in a preferred language. For example, if I want to prepare an SDK for Ubuntu core or the Debian based platform, means actually I can for a C language I can create SDK. While some people wants to implement this Debian based IoT the solution for them, this SDK will be yeah, useful for them to perform the actions actually. Okay, and then actually if you see what are these included SDKs we have in the Azure IoT Hub actually. We have a IoT Hub device SDKs and the IoT Hub service SDKs, and actually it's a platform support will be all these languages like C, .NET, Node.js, Java, and Python actually. Yeah, no, this actually this SDKs which are provided by Azure is young almost supported in all the major languages actually. Okay, and then actually if you see in which languages actually this Azure IoT Hub device SDKs are there actually at current present actually. If you see means if you have in C or C Sharp, Java, Node.js, and Python. But among this actually, as I told earlier, this key can be easily quoted for your microcontrollers actually. Okay, and then actually if you see in which platforms or actually if you see this device SDKs are compatible, means actually if you see we have a Linux, Windows, Embed, Arduino. You know, Arduino if you have Hufasa, ThinkDev, and Fedorama, or we can use the free RTOS using the ESP32 or ESP8266, and then some .NET variations like 4.5. I need to include the .NET Core also. We can include it here actually. Okay, and then the Intel Edison as well. Actually, these are the platform which are compatible to your Azure yeah, the IoT Hub device SDKs actually. Okay, what is Azure IoT Hub device SDKs protocols we have been having? There are some protocols called MQTT, MQTT over WebSockets, AMQP, AMQP over WebSockets, and HTTPS actually. Okay, by this time, the nature of your the protocols which have been used to send the data from your device to your IoT Hub will be using the MQTT, because it's a message queuing transfer protocol actually, which been it's just a lightweight, and it can be broadcast that data in an efficient way actually. They didn't given to in a place where the network coverage is actually very feeble actually. Apart from this actually, the people also using TCP/IP protocol as well to transfer the data from your device to your from your device to your cloud actually. Okay. Okay, while I'm working on the Visual Studio Code code actually, what are the extensions I need to learn the code for actually? If I want to work on this in Azure IoT, there are some things like Azure IoT Hub Toolkit, Azure IoT Edge, and Azure IoT Device Workbench. These are the extensions we need to look for whenever we want to work on the Azure IoT, and then and these are some PLI tools actually which we need to work which is a mandatory one while we have needs to work on in Azure IoT. Okay, and actually we need to uh, add this on Azure extensions, and these commands will be useful for you. And then actually, what are the hub commands we can execute using this the Azure CLI, and by running these commands, actually, we how it will be get executed, like, will be given here actually. Okay, and we have a in your Azure portal, we have a Azure Cloud Shell actually, which is running based upon the Dash or PowerShell with many Microsoft or third-party tools installed pre-installed in it actually. Okay, kindly make leverage of this Azure Cloud Shell then and there actually, so it will be easy for you. And this Azure CLI is actually will be daily fit for this Cloud Shell to perform the various things in the recent times actually. For the past 1 year, this the commands which are mentioned in Azure Scale are improving day by day by the Microsoft actually. Okay, and then actually, if you see, next one we are going to see about the till now actually we seen actually about in how to do it in architectures, what is in IoT Hub, what is in the life cycle of devices of which has been created in IoT Hub actually. And then actually what are the important SDKs, device SDKs, and then actually the ID SDKs actually, and then actually service based SDKs which we need to use for your projects actually. And then we are next we are going for the device configuration and communication part actually. Okay, where we have two types of the device configuration and communication pop-up cart here actually. The one is called the device to cloud and cloud to device. We can send the mm, the actually the always the communication between your uh, device and cloud should be in a bi-directional way, because actually if I am sending a device the data to the cloud actually, it will needs to consume and needs to perform some analytics. After performing some analytics actually, the some alerts or something the device wants to see, the cloud wants to send to data, means that communication also to be opened actually. Okay, so in that case actually the bi-directional communication is really important in this uh, Azure IoT ecosystem actually. Okay. Okay, as I told you actually, and I actually shown you there before, Gotor actually used. Sorry, as I told you before, actually, what are the communication protocols we have, and in the which can be used to send the data to the Azure IoT Hub actually, means actually we have MQTT, MQTT over subsockets, AMQP, AMQP over WebSockets, and HTTPS. Now we will see what are difference between them and which port they can be used actually. You usually in MQTT and MQTT growers WebSockets actually, all the WebSockets based protocol communication will happen when the 443 port actually pins actually. Yeah, it has been coming out with some security certificates actually, like X509 or some other certificates which the data has been sent from the device to the cloud. And then actually then the default port of MQTT is 8883 actually. And then we need to use this protocol actually. If you see in MQTT, then we need to use means actually uh, we can you use this MQTT the protocol on all the devices actually, that you should not require to connect multiple devices over the same TLS connection actually. Okay, and actually gatekeeping can be used only on the non-field and cloud the gateways to take advantage of connection multiplexing across the devices. And for HTTPS actually, uh, if my device or the IoT device which I am having doesn't support any of the MQTT, then AMQP or TCP or UDP actually, means in that case only I'm going to go for the HTTPS actually. Okay. Actually, what are these communication protocols which we seen before should be considered actually? Cloud to device patterns. When you have a cloud to device pattern based consideration means in that case you need to using in HTTPS actually, because it requires a server pooling rather than this server push actually. So cloud device messages are not deficient if you use this protocol. Okay, when in field gateways actually, we need to use in MQTT and HTTPS, which do not and for the as we know earlier actually, MQTT and HTTPS will not support sharing a single TLS connection. So for low resource devices, MQTT and HTTPS are lighter weight libraries compared to the JMQP libraries actually. Okay, in network traversal, uh, yeah, the previous slide we have seen some codes are there actually to being used by these particular protocols. From code only we can traverse the data from the device to the cloud actually. If you see for payload size actually, both MQTT and JMQP are actually they follows the generic protocols, and just the payloads are more compared than the HTTPS payloads actually. So in that if your payload size has to be reduced means actually in that case we need to use the in MQTT and JMQP the protocols actually. Okay, actually, till now, actually, we actually covered actually the things which are all necessary for the IoT hub, and what are the protocols we have been seeing in architectures, and what is the usage of IoT hub and in IoT devices actually, and then actually what is the like life cycle of an IoT device which been created in your IoT hub, and the SDKs which we need actually, or the IDs which we need to work out with this IoT based use cases actually. Okay, next we are going to see how to provision this device actually. Okay, till now, do you have any doubts actually? Any queries you guys have?
I think no questions so far from the audience.
Okay.
How about Håkan? Do you have any questions?
No, I don't think no questions so far.
Yes, thank you.
Okay. Yeah, actually, next we are going to speak about the devices and the device provisioning actually. Okay. If you see actually, there is a difference between a registration of a device and a provisioning of a device actually. Okay, if you, what is the registration of a device means, it just adds a device to the cloud actually. In the and then it got registered into your provider's device list actually. What is a provisioning means actually, we need to configure the device actually with some desired configuration after the registration of the device. For example, the registration has to be happened before the provisioning. Once the registration happened, only we can do the provisioning actually. Uh, DPS means actually it's a device provisioning service. Does this through an initial device twin that is copied into the identity registry on the associated IoT hub actually. Okay, and then this what is this provisioning process is consist of two phases called manufacturing phase and a cloud setup phase. The manufacturing phase, when the device is created and prepared at the factory, and the cloud setup phase when a device provisioning service is configured for the automatic provisioning actually. Okay, and then actually if you see what are these features of this device provisioning service means actually, it's like secure attestation support we can get actually. The first and most important thing is actually we have a trusted platform model based identities, that is TPM based identities actually, with some 5509 certificates. And then actually it is it can also, for example, if I have a device A means actually the device A can connect to multi hub actually, like IoT hub 1 and 2 actually. So multi hubs hub support will be done using this device provisioning service actually. And then actually monitoring and then monitoring and diagnostics logging to make sure everything is working properly also will be configured in this device positioning service. And then if you have it has a cross platform support actually. This device positioning system in SDKs will work on um, variety of operating systems and in multiple languages actually. And then if you see HTTPS and DMQP and MQTT protocols only, this SDK will be supporting actually. Okay. Okay, then we want to use this device positioning service means actually, uh, if you want to do a zero touch provisioning, load balancing, connecting devices, deprovisioning, and rolling out the keys of your device actually. What is always zero touch provisioning actually? For example, if I have 1,000 devices needs to be enrolled actually, yeah, I can't go to each and every device and produce a certificate for it. For that actually we have an option called a group enrollment of these devices in DPS. We should be creating a this 1,000 devices, and actually it's providing the extra 509 certificates as commentary keys for that particular device. And then they are making this as zero touch provision to devices actually, yeah, without any extra uh, uh, time to make them daily actually. Okay. And each every device which is created using this DPS is using a load balancing, and they have been they connected with the devices, and we can able that now we can able to have a deprovisioning of these devices actually. And then the keys which are used for this as a part of security for those devices will be rolled out easily to the each and every the physical device which is attached in the clients actually. We have a DPS. The concepts called service operations endpoint, device provisioning endpoint, linked IoT hubs, allocation policy, enrollment, registrations, and operations. What is my service operation endpoint? Is the service operation endpoint used for managing the DPS and the enrollment list, and device provisioning endpoint is to single address is will be used for provisioning the STAD across all the customers and DPS instances. And we have linked IoT hub actually. Once your DPS is created, we need to link it with our IoT hub to know which is your target IoT hub to receive the messages actually. And enrollment is nothing but actually it's a group of on record of devices that mean registered against the DPS. And uh, the operations means actually the billing unit of DPS once successfully completed the request. What are the device enrollment types? As actually telling you before, this group enrollment and individual enrollment. Then individual enrollment will be always following a single entry for single device that may register, and it may use X509 certificates or class tokens as in attestation mechanisms. And group enrollment means actually it is having a group of devices that acts as a share common attestation mechanisms actually. Okay, so uh, yeah, if you see actually for individual enrollment, actually we can use the SAS tokens, and for group enrollments, actually we can use some X509 certificates for 1,000 devices which are created here. In that, actually, which can be having some good certificates or in intermediate certificates, which is used to produce this device certificate on the physical device actually. Okay, and then actually, if you see what are the device enrollment concepts we have actually, the device enrollment concepts we have are the ID scope, registration ID, device ID, and the attestation mechanism. If you see the ID scope means the each and every device which is created, or DPS which is created actually has been differentiated by means of this ID scope, and registration ID is nothing but It's uniquely identifies a device in the DPS instance, and device ID is nothing but actually it's uniquely identifies a device in the associated IoT hub instance. And then as I know, attestation mechanism is nothing but actually it's a security mechanism which needs devices to prove its identity to the DPS by means of symmetry key or X509 certificates actually. Okay, now we see actually we are coming to this security concepts called certificates actually. We have three types of certificates, sorry, the security concepts we have been using for the device level. One is X509 certificates, which are digital based identity certificate, which is based on private public key pairs and a chain of trust, which is issued by certificate authority. And they have some the rule is actually the chain must be trusted, and we should have a DPS in group or in individual enrollment actually. Okay. Actually, if you see in the that is actually in the cloud level, we have the certificate concepts called these certificates. But in the hardware level, if you see, actually we have a HSM and TPM. What is mean HSM means actually it's a hardware security model which is used for secure hardware-based storage of the device secrets, and we have TPM called the trusted platform module, a specification for storing your keys for the which can be communicated with the HSM actually. Okay, the two hardware keys for the TPM are the endorsement key and the storage root key. What is my endorsement key means actually it's a unique identifier for the TPM, and it's a read only injected by the manufacturer. The storage root key is means it is used to protect the TPM secrets, which is generated when the user takes ownership of the TPM actually. And this is your DPS not of provisioning behind the scenes actually. If you see actually the DPS will be created and it will be linked with your device and sent to the IoT hub, and then the enrollment the list will be created. Once an enrollment list is created, this DPS will be non provision when the device is going to delete, and once again the cycle continues actually accordingly. We see an enrollment list means actually the manufacturer adds in registration to the enrollment list. That is the first step. And the second test, if you see actually the DPS, the device contacts the DPS passing the identity information. That is nothing but your attestation one. And then actually the DPS then validates the identity of the device. And then actually if you see in the fourth step, the provisioning service registers the device with an IoT hub and populates the device desired in state. And once this provisioning has been done, actually the IoT hub will be returns a device ID information to the provisioning service actually. And then actually in the sixth state, if you see the provisioning service returns in IoT hub connection information to the device, the device can now start sending the data directly to the IoT app. The down step is actually, if you see, the device and IoT app is making that communication actually smoothly. Once this device provisioning service authenticates that this device ID can send the data to your IoT app actually. To see what are the device provisioning service in this case we have, or uh, the provisioning the device client SDK, which is enables you to build the apps that run on your IoT devices, to which needs to communicate with the device provisioning service, and then the provisioning this service client SDK, which will be enable you to build backend applications to manage your enrollments in the device provisioning service. And we have some additional tools like TPM simulator and X509 certificate generator to make the attestation process in a day smoother way actually. Okay, actually we are coming to the end of the presentation, which we actually which actually covered almost all the topics which are required for a beginner who wants to work on Azure IoT Hub. And then we are now moving to the hands-on session. Whatever the jargons or things which have been seen here actually will be done it and explained in the Azure portal, and it can be very useful that you can also be understand that what are the terms which have been used till now in this presentations actually. Okay, till now any doubts you have means you can ask me actually. Any doubts we have, Jonah, from the audiences?
No, I
Hello.
think no questions so far at this point. So you can
Yes,
just
Okan.
continue. Yeah.
Okay, Okan. Yeah, sure. Yeah. Yeah. Yeah, I hope so actually. In everyone, yeah, actually, yeah, has your Azure free pass. I hope so. Okay, if you guys doesn't have, actually create one Outlook account and log in with that Outlook account, and then actually uh, we have a free tier actually which have been used um, to perform this workshop. Okay, yeah, actually in this, yeah, this is in Azure the portal. Actually I hope so the persons was uh, familiar with this actually they know we have a list of services actually available here actually, and I actually I have been they told about the cloud shell actually which is here, which leverages the dash commands and PowerShell as well, like commands as well. So if you see, we can leverage it most of the things from this cloud shell as well, and we have a notification bar and then the directories actually in which directory you are currently, and actually we yeah, I have a default directory which is under the subscription called pay as you go. So actually if you see, all the details which is related to an account can be verified here actually in this directory. And if you want to know about your billings and everything actually, if you see here subscriptions, you can able to see, yes, yeah, since I'm using the pay as you go subscription, actually I mean placed as a pay as you go. Well, yeah, but actually if you are using the free tier means you have been assigned to a subscription name called the free tier actually, and my goal is an account admin actually here. Okay, yeah. Next actually, these are the some of your services which are offered by Microsoft, and then we have a dashboard and home, and yeah, yeah, this is our home. And if you want any the services to find, actually we have a if you type this name here, actually it will come up here actually, IoT Hub or Cosmos to be everything actually. Okay, yeah, yeah, this is a little introduction about this platform so that it can be which was told to for the people which are new here for this Azure cloud platform. So now we'll be moving into how to creating IoT services here actually. Okay, first of all, before going to, we need to create a resource group actually so that it can accommodate all the necessary service of this workshop, yeah, under a single grouping actually. Okay, so go to resource groups, click create. You can see your subscription here. Okay, and then click and you need to give some name for your resource group, like Azure IoT workshop. Okay, and then region, actually you have a lot of regions here actually. So in which under region your resource has to be created. As of now I'm creating as a east us. Next we are need to going for a tag. I am not giving any tags or values for this resource groups, and then I am actually creating it. Okay, yeah, if you see my resource group has been created here actually, which contains your subscription details, your subscription id, your location, your tags, and you can also have see what are the activities has been happened in your iot and this particular yeah, resource groups. And then actually you can see what is the cost of this exclusive resource group actually, apart from your entire billing actually. And then you can control the access as well actually, like to whom I need to give the access for this resource group from a particular team. Okay, so you have some access like user group or service principal or user assigned in manager identity, and we have the roles like owner, contributor, and reader actually. And then AC or push content reader, and we have some number of roles here actually. But usually if I give a contributor goal for a, yeah, particular person, if you see actually he can be able to create any resources under this yeah, particular resource group actually. Okay, these are some short introduction about this resource group. And then actually now I want to create a Azure IoT Hub actually. Okay, if I actually went here and choose the IoT Hub. Okay, if I see I got this page here, I need to go and create IoT Hub. In this create IoT Hub I can able to see what is the subscription I have. Okay, and then I need to select my resource group which I created, under which resource group this IoT Hub has to be created. And then I need to give a unique hub name, like IoT Hub workshop WK shop. And again the region, we can give any region here actually. But actually I always wish to go with east us or east us too actually, which is in these year regions yeah, for me. But actually if you are from Japanese or Japanese also, you can be able to give it in accordingly the regions which you prefer actually. Okay, and then actually if you go for network, actually we have a connectivity method called public endpoints, private endpoints actually. Okay, if you want to go for private endpoint, yeah, they need to choose which VPN has to be connected actually. Or if there is no any VPN is there, means you need to create one VPN actually, because via this VPN only actually all the data will be tossed actually if you create a private endpoint based IoT Hub. But actually now we are going to a public endpoint based connectivity method, where all the data from your from devices from whichever might be the network can be sent to your IoT Hub. But in a private endpoint we can send data from a particular network only to your IoT Hub actually. So for this reason only we have this configuration here. The recommended one with it's to go with private endpoint. But actually since since it's a workshop kind of thing actually, and it's not any base production environment actually, we are going up with the public endpoints actually. Okay, and next if you see the management, yeah, before this actually I might have told you what is the tires we have actually in our IoT Hub actually. Okay, so if you just see my slide actually here, this is the place I was telling you actually what are the tires we have, S1, B1, B2 actually. So if you see here actually, we have the S1 standard tire, S2 standard tire, S3, B1, B2, and F1 free tire actually. So each and every one actually, every standard tire has this uniqueness. If you see here, if I choose a S1 tire, we can send per day 4 lakh messages, and the costing of it is around is actually 1,800 actually. And we have some costings for different from IoT as well, where some these some of the other features like device to cloud messages, message routing, cloud to device commands, IoT edge, and device management also will be enabled for this particular standard tier. But now if I go for S3 tier, if you see actually the pricing was got increased, and where actually sorry the number of messages per day got increased, where the costing also got increased. So based upon your use case actually, you need to select these tiers wisely, so that it will be easy for you to manage it, and I can be able to yeah, there won't be any unnecessary message loss will be there actually if you choose a long tier. For example, if my your use case is sending uh, above 5 lakhs messages per day, but I have only S1 tier only actually for my IoT hub, means we unnecessarily will lose 1 lakh messages per day actually. So in that case actually you need to choose in S2 tier actually. Okay, so based upon your use case and number of messages if you are sending actually, this uh, tier should be yeah, chosen wisely for you actually. Okay, and if you see here what is a tailor's version, usually I need to go with 1.0, so I am going here, and we need to also partition this device to cloud partitions actually. Okay, based upon your device actually, the device to cloud partitions will be for most of the IoT hubs actually. And then actually if you see Defender from IoT can be switched off or switched on. Actually, if you want, you can keep or you can, but it's really useful to turn on this button actually, because it protects various threat actually. Okay, and then actually, if you see, I likes to go with S1 tier, or the free tier also I can go with. I hope so, but if I go for free tier, means if you see 8,000 messages only I can get, and some things are not there for me actually when it's there in S1 tier means actually. Okay, so I will go with free tier, since it's a workshop, and you guys also go with your the free tier actually. And you need to understand only one free tier can be created per one subscription actually. So okay, you can't create one or more free tiers for subscription. So keep this also in mind actually. Okay, and then actually the tags I'm not giving anything, and then actually it's going to give you my IoT hub, and then actually once the validation check has been passed, I have been creating this IoT hub actually. If you see the deployment is under progress, yeah, till this section, any doubt you have, guys? Actually, any queries from the attendee side till this step while still creating the IoT hub? Hello.
Yeah, no, I don't think we don't have any questions from the audience.
Okay, Okan. Yeah,
No.
okay, sure. Thank you. Yeah.
Thank you.
Once this IoT hub got developed, it's got deployed actually, and then we need to see the. I have been told about that the device provisioning, and then actually routing and defender for this IoT hub. I will show you each and every one and match with my slides actually, so you can also understand till now the whatever we have been seeing actually. Okay, till this deployment is done actually. Okay, if you see actually, we can see that the deployment for this IoT hub got completed, and we are going to the resource actually. I hope so everyone has been created this IoT hub actually. Okay, and if you see once you if you see actually in this resource group, I will show you actually under this resource group this IoT hub got created, and if I click it actually, it is going inside. And actually we have some details regarding it actually, like what is a subscription, what is a subscription ID, how many number of IoT hub units we have actually, what is this pricing and sale, what is this host name and all actually. Okay, and then actually this is some of the overview of your IoT hub, and I already told I have access control also for this. And actually if you see here in one place I have been telling it about the certificates, and then actually built-in endpoints and all actually. If you see here actually, if I go for this shared access policy, if I click IoT of owner, actually I can get a primary connection string actually, which is used for n number of purposes actually to get authentication of your device actually. And then actually if you go for identity, it will shows which IoT hub is connected with your devices, and pricing the scale and certificates actually. If you have any if you want to, after creating your X509 certificates actually, we can collect here and we can upload the certificates here actually. Okay, and then actually if you see we have a explorer from IoT devices, where in IoT uh, devices actually has been some problem is arising. I will actually check onto it. 1 minute. Okay, I will look onto this error actually. If you see actually we have a IoT devices, IoT edge device actually, and its creation place actually. And then if you see message routing from I have been telling you about the message routing from where to where this data has to be sent from the IoT hub actually. And then actually if you see some of the common things called alerts, metrics and logs has been there for this young IoT hub actually. Okay, yeah, these are some of the yeah features we have been screening in our this thing actually, our the slides itself actually. So I hope so you guys have been have some detailed explanation on it, yeah, while I am going on through these slides actually. Okay, this is IoT hub endpoints actually, where 1 minute, in routing if you see we have a option called a creation of custom endpoints, and then the routes actually inside the custom endpoints you can see your event tabs, service bus queue, service bus topic and storage and all actually. Okay, okay, this is what all got explained in this slide as well. Where are the topics we have like that actually. Okay, okay, yeah, till now I hope so you guys are clear actually. And now next time going to create a device actually with some symmetry key authentication. So once it is got created actually, I will share the program for this simulator with you, so that the program can be leveraged using your the Visual Studio Code. And then actually if you have a if you guys doesn't have DS code to run those stimulator program, means actually we have a online based Azure stimulator actually for to send Raspberry Pi stimulator to send the data to this IoT hub actually. Both the things I will actually show you. So which one is convenient for you guys, you can be able to adopt to it actually. If you see here actually online stimulator for online simulator in Raspberry Pi, if I give means, see here we have a ready-made online simulator for Raspberry Pi actually. Okay, so they are this complete simulator was written in Node.js actually. Okay, so it sends only the temperature data and cluster data. We have a resemblance here. The Raspberry Pi is connected to your DM. I hope so. Actually, it is a DM2 85. I hope so. Actually, this is this sensor actually. So yeah, okay, yeah, BME the 28 0 sensor actually. So based upon this stimulator actually, it will be sending the data back to your IoT hub actually. Okay. Um, or else actually we can send via like this also, or we can use our DS code and we can send it out. Both the things I can show you now, so that it will be yeah easy for you guys to understand actually. Okay. Okay, in this overview of the IoT hub, if you see actually, in this, these are some stands actually where I can see how many messages I got actually, how many messages was sent today, how many messages I can send, how many devices can provision here actually, and how many devices was sent to device to clouds and connected devices, are how much is there actually. That kind of uh, analytics or data can be found in this usage tab actually. Okay, and if you want to get started with this IoT hub actually, we have some good Microsoft learn documentations, which is daily good thing actually, which can be started from here as well actually. Okay, now I am going to create an IoT device actually. 1 minute, I am signing out and logging out and signing in again actually. Okay, I hope so. This subscription doesn't have rights to create that name, so I am creating an IoT hub with yes one. I'm deleting this one and I'm creating it with this one tier actually. Okay, some issue was there in this the free tier actually. Okay, so do you guys also delete this free tier actually, and then create an IoT hub with this one tier actually. Okay. So I am creating a new one. Mm, IoT hub. Sure. Then this is fine. In management, I'm giving the S1 standard tier, then tags, and I'm actually creating the things. After validation, it will be get deployed. After it gets deployed, I'm going to create two devices with okay, and then actually I will show you how the data is getting routed actually to the particular place. Once this deployment gets completed, we will be continuing the things actually. Meanwhile, this deployment goes. I am creating a storage account for us by with the which contains a blob container, a storage account is nothing but is a place actually where your data which is passed from your device to cloud will be stored actually. Usually this storage account will be used as a cold path actually, where the data will be stored here, will be utilized for long-term purposes actually, or as a batch for the batch processing purposes actually. Okay, so I am creating a storage account here actually in this resource group. So for that, once our simulator, once we create a device and starts our simulator, we can see our data in this blob storage actually. Okay, shop storage account. I'm going for a standard performance only, and then actually what is created. I don't want to enable anything here in advanced setup. In blob storage, you can click it infrequently access data and backup scenarios. Frequently, we have two things, hot and cold. I'm clicking for cold one here actually, and then actually if you see networking, data protection, and then actually yeah, I am going to create this storage account after doing validations actually. Okay, still we will go inside this IoT Hub. Okay, as I explained before actually, I already explained these things actually. Since see here actually, once I change my free tier to the S1, I got the daily messages, the quota got increased actually. Okay, and then actually give your yeah, IoT device actually, and then what is this error actually? IoT Hub unauthorized access, unauthorized error tracking. I don't know what's this error. Um, okay, I am actually changing my subscription actually. Okay, and so that it will be better. Okay, and this error is coming. Okay. I actually yeah, changed my subscription here. Okay, so I am creating a new resource group. Since I faced some issues in that subscription, I changed to my regular one, which I have been using daily. Inside this resource group, I was creating my IoT Hub. Okay, then actually I have been giving the shop hub. Okay, in the standard tier, and I'm creating it. Meanwhile, I will, as I told before, I'm creating a storage account. Mm, then actually, once I create this, I hope so. Our both the things are under deployment state actually. So once it got deployed, I will be creating the devices actually in IoT Hub. Once that is completed, actually, we'll be sending the data to this respective containers actually from the devices. Okay, I'm going into our IoT Hub. Okay, and then actually I am creating the device section. Don't know what's the issue here actually. John, actually, hello.
Yes.
Yeah, John. Actually, I am actually I'm for 2 minutes. I am cutting my screen share actually. Okay, I'm facing some issue related to network. I hope so. Since my subscription was not retrieving. Yeah, give me some 2 minutes. I'll be back to the screen share actually. Okay.
Okay.
Yeah.
Hi. Hi,
Hello.
Makan. Hi.
Yeah, so I
Yes.
guess we are all aware of that there can be some technical problems here, but I guess in the meantime, what we can do is we can share a very nice learning path here from Microsoft Learn, which is an
Yeah.
introduction to Azure IoT. So
Yeah,
let
sure.
me
Sounds
post
great.
that as a comment here. Learning path on IoT. I can recommend that learning path for any one of you, regardless if you're just curious about what IoT is and want to learn more, or maybe you're actually targeting the Azure IoT certification. So this can be a very good basis to start out from.
Yes.
Have you done
Yes.
anything with IoT, Jonah?
Yeah, actually, I have. I bought an Azure IoT starter kit that I started like months ago, but I haven't had time to get to continue working on it. But it's really interesting to work with IoT, and I have a big planned project to like kind of like make like a weather system or temperature system at home or a camera system, but it's a big thing. I need to know the basics. So this session is also interesting. How about you?
Yeah, I think we have the same device actually, the Microsoft device, and in addition to that, I also have a Raspberry Pi, so that I've been playing around with, but nothing too serious.
Yes.
But if I'm not mistaken, you like to grow different things like plants and flowers and stuff. So maybe you can build your own self-sustained watering system.
Yeah, I know that here there's a company here in Sweden called Solid Technology that they're making. They're using Azure IoT services to plant. To do irrigation systems for the plantation. So, but unfortunately, they don't sell those devices for like private use. I could use it in my garden, but they don't. We have an input from Gabriel. Cool T-shirts.
Oh, thank you.
Thank you, Gabriel.
So,
Yes.
so what is this T-shirt actually? What is it? Where does it come from?
Yeah, it is Azure Heroes T-shirts. So yes, yeah, I got this T-shirt when I received the Microsoft swags and for learning and speaking. So how about you? You got yours also from community work.
Yes. Yeah.
Yes. Yeah. Maybe Gabriel will be able to get one. So we hope that one of these days we will be able to, like coming sessions, we will be able to share Azure Heroes badges and Microsoft swags with help of Microsoft here in Sweden. So hopefully next session we can share some gifts to the audience and learners. Yes. Okay. I hope that our he's coming back. He was having issues, I think, with internet, right?
Yeah, let's give him a little bit more time, and we can.
I understand.
See here.
Yes. Yes. I wish we could. It's too bad we cannot add in our audience so we can do a discussion. Yes. Yeah.
But we could ask. We could just ask an open question to the audience. Have you had any experience with IoT, or what is your interest in IoT? Could you just answer in the chat?
Yes. Maybe we can add it this question. Okay, questions to the audience. Let's see. Let's show that. Okay. Let's see if we get any response from our audience. Any experience in Azure IoT? I wonder.
It might be maybe Gabriel has some. He was talking about the IoT web simulator, and he was asking some questions about the Raspberry Pi.
Yes, I think he is an expert of Python language. Yes, so maybe, there's, we have a question from, you can do it.
Okay. Yeah, so we have a question from Gopal. So Gopal, he says, I did work in IoT a while ago. Also used Azure IoT Hub with Cosmos DB for some remote devices. And we should also say that Gopal was one of our previous speakers. So if you have a look at the YouTube channel, you can find his session there.
Yes. Yeah. That's correct. Yeah. I know that Gopal had a blog about an IoT system that he made like a few years ago. So that is also worth checking out. No question, no more any experience. Let me just check how's he is rejoining. He should be back soon.
Oh, good.
Yes. Okay, that's good. And Gopal said, let's see, let me show this one. Gopal said, I had also worked in lower layer of IoT using Raspberry Pi and some basic electronic components. Yes, that's great. Yes. Maybe we should have another session with Gopal about that project.
Yeah.
Yeah, that's good. That's great. What? How about you, Håkan? What have you tried? I know that you have an IoT device too. What
Yeah.
project have you tried so far?
Yeah, so I've basically just tried to make, some LED lamp blink and this stuff. So I haven't connected it to any device yet. But I was thinking of maybe make like a temperature sensor,
Yeah,
so that it can maybe it can send some message when the temperature goes above or below a specific threshold. That could be nice.
Yes. Let's see. We have him back.
Yes.
Let's see.
Let's
Okay.
add him back. Hello.
Yeah, I'm sorry for the delay, and I have some.
Maybe there are some internet issues.
Yeah,
network
that's
issues.
network issues for him. We will see if he will be back soon. We apologize for the inconvenience for the audience that are there right now. So we apologize for the technical. We're having technical issues for now. But in the meantime, I want to show you. I have I bought this one, and this is the IoT Dev Kit MX chip that I started testing, and it looked like this. It's very small. Is this the same that you have, Håkan?
Yes. Maybe you can show it now.
It's hard to show. Yeah, but it's small. It's about the same.
Maybe we should also mention that in order to take this learning path on Microsoft Learn, you don't need to have a physical device. So you can do everything with simulated devices. And right now
that's good.
Mm-hmm.
That's good. I really like that web simulator that's in there. You just enter your ID and the connection strings, and you can run and test it.
Okay, so now let's see. We have
he's
trying
again.
Connecting. And
yeah, hi Jonah. Sorry for the delay. Actually,
that's fine.
Yeah, actually, yeah, Jonah. And how can? Yeah, can you be able to hear me?
Yes.
Yes,
Okay.
We can hear you.
Yeah, sorry, there is a technical issue in my side. Actually, now it got resolved. Yeah, can we go ahead? Actually.
Yeah, sure. Please go ahead.
Yeah, thank you. Yeah, hello. Yeah, sorry for the interruption. Actually, I had some technical issues, and now it got resolved. Actually, if you see here, actually, the issue is related to the cookies in the browser. Actually, it got some based upon an error message earlier we got. Actually, I came to know regarding it, If you see actually now that issue got resolved actually, and then actually we are now actually going ahead to create a device actually. It's my voice is clear to everyone.
That sounds loud and clear.
Yeah, actually we are now going to create a device in our IoT Hub. Yeah, it's so sorry for a delay. Actually, it's getting delayed for me due to my network issues. Yeah, it's going inside now. It's getting delayed. Sorry.
Yeah, so it looks like
I
we
think
have some problems.
yes. I think we're all out of time soon, so we will see if he comes back. But we will see. If he doesn't come back, maybe we should. I don't know. Maybe we can like show a learning path for Azure IoT or something.
Yeah. Mm.
Yes, we will see. You can play your favorite music. Yeah, maybe
Yeah, so
it's yeah. I'm
Yes, I
sorry.
can,
Go ahead.
I can also mention that most of the things that Saravana has described in his presentation, you will also experience if you go through this learning path that we posted in the comments or in the chat.
Yes, that's correct. Okay, so we will see if he come back soon. Otherwise, I think we will end our session. I think he was in the. He's back. Let's see. Let's see.
Hey, hello. Sorry, actually, there is a network issue. Actually, it's have happened again and again. It's now it got fixed. Yeah, sorry. Give me some 20 minutes. Yeah, more time to complete this session. I will be really happy. Actually, yeah.
Okay.
Okay.
Yeah.
Can I go ahead actually?
Yeah.
Yes.
Yeah.
Yeah.
We can wrap it up. Yeah, and finish the session. Yeah.
Okay. Yeah, I'm sharing my screen. Yeah, actually, yeah, sorry for the delay, guys. Actually, I had my issues here actually related to the network, and then now we are going to device actually. Okay, and then actually.
Oh. Yeah, it seems like we lost him again here. So I think
Yes.
unfortunately we need to wrap things up here. And for
Yes.
those of you, we are very grateful that you stayed with us so far. And as I said, you can get a lot of information in this Microsoft Learning Path that we were posting. So, but we would
Yes.
like to thank all of
This
the
one.
audience. Yes.
This one. So this learning path is a recommended path for learning Azure IoT. Yes. Go ahead, Håkan.
Yeah, I was saying that we just would like to thank all of our audience and Saravan for speaking. And thank you everyone that you had so much patience with us. And we're sorry for the technical inconveniences. And we hope that we will be able to see you in our next show.
Next
so
session.
Yes.
Yes.
Just keep an eye on our Twitter and keep an eye on our meetup group, and you will be informed.
Yes. Thank you, everyone. Yes. Thank you, Gabriel, for have a great weekend as well.
Yeah. Have a great week ahead also. And see you later.
Yes. Thank you.